So here's the review for section 1.3, sections 1.3 and 1.4. For sections 1.3 and 1.4, this is where we start getting away from the trig functions of only acute angles. We want to be able to take the trig functions of any angle. And so in 1.3, we introduced this idea that if you have a point in the xy plane, x comma y, then there's a distance to the point from the origin, and that angle made theta, the sine of theta is y over r, the cosine of theta is x over r. Now for me, that's because if you drew a triangle out of it, this distance from there to there would be x, and this distance from there to there would be y. And so then you can go back and use SOHCAHTOA to find those. And then the tangent of theta is opposite, or is y over adjacent x. And so if we have a point in the xy plane at -1, -5, that's the angle theta. The triangle that I could draw out of that would look something like this. That being a -1, that being a -5. And the hypotenuse on that triangle is found by a squared plus b squared is c squared. 25 plus 1 is 26, or the square root of 26. And so now we really just think of this as the angle now. So we say that the sine of theta is -5, or y, -5 over the square root of 26. The cosine of theta is the adjacent, or x, -1 over the square root of 26. And the tangent of theta is y over x, or -5 over -1. And you see the signs go away, and it's positive. We rationalize the denominator on these guys, and we get -√26 over 26, and we get -5√26 over 26. So now the other trig functions, or the reciprocals, cosecant of theta is -√26 over 5. The secant of theta is -√26, and the cotan of theta is 1/5. And it was at this point when we started saying things like, oh, okay, well, in quadrant 3 in the xy plane, both the sine and the cosine are negative, and the tangent is positive. So we started making a note that in quadrant 3, just the tangent is positive. And if we continued on by realizing that the cosine is related to the x value, on this side, x is positive, so that means cosine is positive in this quadrant and this quadrant. If the sine is related to the y value, then the y values are positive up here, the sine is positive here and here. And tangent's positive in this region as well. So we say that all of the trig functions are positive in this region. Just the sine is positive in that region, and just the tangent in quadrant 3, and just the cosine in quadrant 4. So a lot of people will memorize that all students take calculus. To memorize where the trig functions are positive. Okay, we'll use that in just a second on 39 and 40. 38 shows you how to deal with what are called the quadrantal angles, or the angles that end up on one of the quadrants. Okay, so the boundary of the quadrants. This is 270 degrees. And in this case, you really can't draw a triangle. So you really do need to go back and remember that x is 0, y is -1, and r is the distance from the origin to that point, which is 1. So the sine of theta is y over r. The cosine of theta is x over r. And the tangent of theta is y over x. You put a 0 in the denominator and it's undefined. Cosine of 270 degrees, or this angle theta, is 0, and the sine of 270 degrees is -1. Now we do reciprocals. Reciprocal of sine is the cosecant. That's also -1. The reciprocal of cosine is secant. 1 over 0 is undefined. And the reciprocal of tangent is cotangent. And this would be 0 over -1, which is going to be 0. All right, so in finding the quadrant where theta lies, you need 2 bits of information. If they tell me the tangent's positive, then I know I'm either in quadrant 1 or 3. If they tell me secant is positive, that means that cosine is positive. That tells me it's either in 1 or 4. But to be both of those at the same time, that means we're in quadrant 1, because they're both positive in quadrant 1. If tangent is positive and cosecant is negative, then that means my sine is negative. Tangent is positive. Tangent's positive in 1 or 3. And sine is negative. The only place sine's positive is in 2 or 1. So sine is negative in 2 or in 3 or 4. So when you look at those together, they both agree on 3. So we're in quadrant 3. All right, so now dealing with the signs of these numbers, meaning the positives or negatives, this is what allows us to find the exact value of trig functions of any given angle. And so in 41, it says that the cosine is 2/5, or cosine being positive, and sine is negative. cosine is positive in 1 or 4, and sine is negative in 3 or 4. So we're in quadrant 4 with this. So I'm going to draw this reference triangle to figure out what the exact value of the remaining 6 trig functions, or I should say the exact value of the remaining trig functions. So cosine of theta is 2/5, and cosine is the adjacent over the hypotenuse. And then the remaining side on that triangle. This is where you got to be careful, because we're going to say a squared plus b squared equals c squared. Or b squared is 25 minus 4, or 21. This looks like it should be square root of 21. However, we need a negative on this. Now we can find the sine of that angle. It's the opposite, negative root 21 over 5. The cosine of theta, well, I usually just write given. The tangent of theta is the opposite over the adjacent. Now the reciprocals are always the easier ones to do because you already have these staring into the face. Cosecant theta is negative 5 over root 21, or negative 5 root 21 over 21. Secant theta is the reciprocal of cosine, so 5/2. And the cotangent of theta is negative 2 over root 21, which gives us negative 2 root 21 over 21. All right, 42. Tangent's negative and sine's positive. So sine's positive in quadrants 1 and 2, and tangent's negative in quadrants 2 and 4. So we're in quadrant 2. So I draw my reference, or I draw my reference triangle, my reference angle in quadrant 2. So I have a tangent that is negative 1 over 3. So the opposite over the adjacent side. Now, Pythagorean theorem, we have a squared plus b squared. That's 9 plus 1 is 10. This becomes square root of 10. Now we can find the value of each remaining trig function. Sine of theta is negative 1 over root 10, which is negative root 10 over 10. The reciprocal, cosecant theta, is negative root 10. Cosine of theta is 3 over root 10, or 3 root 10 over 10, which makes the reciprocal function root 10 over 3. Tangent of theta was given, and the cotan theta then is negative 3. Last one, cotangent theta equals 3, and the cosine is negative. All right, cotangent's positive in quadrants 1 and 3. Cosine is negative in quadrants 2 and 3. This puts us in quadrant 3 again. Oh, look back on 42, and I made one of the most common errors that students make. I'm in quadrant 3, and we said that all students take calculus. So we said that tangent was positive in this region. So there is an error in this. We said that sine is positive. We're supposed to be in quadrant 2. This means then that the opposite over the adjacent, this will still be root 10. All of the numbers are going to be the same. However, I'm in quadrant 2, so sine has to be positive there. Cosine is going to be negative. Positive and negative. So the moral of the story is be careful with your signs on these problems. You have to be the one that knows which one gets the negatives on these things. Now look at this one. Cotangent theta equals 3. So I know I'm in quadrant 3 here because cotangent is positive and cosine's negative. Thinking this is 3 over 1. Cotangent is adjacent over opposite. But notice how in quadrant 2, this would be a negative x and a negative y. That's important. You got to put those on there. We're dealing with pretty much the same numbers here, 1 and 3. So this is the square root of 10. And then we've got the sine of theta. Opposite over hypotenuse. Cosine of theta. Adjacent over the hypotenuse. Tangent of theta. Opposite over adjacent. Negatives cancel out there. Cotangent theta was given. The secant of theta is root 10 over 3. Negative, I should rationalize this denominator. And then the cosecant of theta is negative root 10. All right, so again, we're looking at angles that are no longer acute, can be larger than 90 degrees now. So it's all about reference angle. When we drew these triangles, the real angle is the one that goes all the way around to its hypotenuse, and then this is thought of as the reference angle inside. And they use the notation with a little prime on top of the theta for the reference angle. So when I'm looking at 265, I'm thinking, well, you went just a little bit shy of 270, like 5 degrees shy of it. My reference angle is always found by forming a right triangle with the x-axis. And so it's just a little bit past 180. I want to know how far past 180 it really is. So I do 265 minus 180. 85 degrees. Five pi over 8. I remember that this would be pi over 2 or 4 pi over 8, so it's just a little bit past that one. And so I need to find the reference angle that's sitting here. So I do pi take away 5 pi over 8. And so that's 8 pi over 8, which it gives us 3 pi over 8. Negative 410 degrees. So this time we're going back around 360, and it's about 50 degrees past that. The reference angle is this angle sitting right there. And so I do negative 410 plus 720 degrees to get it to be positive. So that's 310 degrees where we went around this way. And then I can find theta prime by doing 360 minus 310, which gives us 50 degrees. Uh, 17 pi over 6, if I go around one time, that would be 12 pi over 6. Because that'd be 2 pi. And I go around another 5 pi over 6, which puts me there. As a general rule of thumb, when they're in radians like this, the sixes and the thirds, your reference angle is pi over 6. Or in 48, pi over 3. But to do this formally, we've gone around one time. We want to take that 2 pi out of it. Which gives us 17 pi over 6. 12 pi over 6, or 5 pi over 6. Sorry, this isn't theta prime. But now we see that the 5 pi over 6 is just shy of the pi mark. And so we do 5 or pi minus 5 pi over 6, which is pi over 6. Negative 11 pi over 3. We take negative 11 pi over 3 and try to get its positive angle first. So if I added 2 pi to it, it wouldn't be positive, but if I added 4 pi, that'll be 12 pi over 3, which gives us pi over 3. If that turns out to be an acute angle, then that is our reference angle. Okay, so what this does for us is if you have an angle theta that is bigger than 90, this is when I'm going to go back up. This is when I'm going to use what I showed you a little bit ago. This table right here. Now I'm going to generate it one more time because it's going to be useful. When we have an angle, say theta, it has its associated reference angle. And the sine of that angle theta will always be equal to the sine of the reference angle, but plus or minus of it, depending on which quadrant we're in, because we said that sine was negative in quadrants 3 and 4. Cosine of theta. We find the cosine of theta prime, and then we put a plus on it if theta is in quadrant 1 or 4, and a negative on it if it's in quadrant 2 or 3. So that's why we spent a bit of time doing reference angles. So when I look at 240, I need to know what its reference angle is. So I know that 240 went all the way around past 180 or 60 degrees past it. So it's equal to the sine of 60 degrees, but plus or minus of it. But since I'm in quadrant 3, I know that the tangent was the only one there positive. So this is a negative. Tangent 120. 120 sits here with a reference angle of 60 degrees. So this is equal to tangent of 60, but plus or minus of that. And we said in quadrant 2, all students, or sine is the only thing positive there. This is going to be negative. 51, secant of 7 pi over 4. Now I'm really going to think of this as 1 over the cosine of 7 pi over 4. These ones are easy because when you see fourths in the denominator, that means your reference angle is pi over 4. Remember, it's plus or minus. I don't know. Remembering that 7 pi over 4 sits in, there's 1 pi over 4, there's 2, there's 3, there's 4, there's 5, there's 6, there's 7 pi over 4. It sits in quadrant 4. And remember, that's all students take calculus. That's where cosine is positive. Obviously, I'm not done with these problems yet for 950-51. I now need to say what those values are, but I'm just showing you how this works. The cosine of 11 pi over 6 is the same thing as the cosine of pi over 6 because that's its reference angle. And 11 pi over 6 sits in quadrant 4, and that's where cosine's positive. Negative 210 degrees. That goes back to 180 and then another 30 degrees right there. Our reference angle is 30 degrees. But since we're in quadrant 3, that's where cotangent, or that's where tangent is negative. So we're going to have to put a negative sign on that. Okay, so I've done this long enough. We're going to go back now and remind you the table. $30, $45, $60. The sine of that angle is 1/2. The sine of 45 is root 2 over 2. And the sine of 60 is root 3 over 2. The cosine flips and goes the other way and gives us root 3 over 2, root 2 over 2, and 1/2. And then from that, I use that the tangent is sine over cosine. And 1/2 over root 3 over 2 is 1 over root 3, or root 3 over 3. Root 2 over 2 divided by root 2 over 2 is 1, and root 3 over 2 divided by 1/2 is root 3. So now with that little table in hand, I can go back and finish all these problems. Sine of 60, I go over here and I see it's root 3 over 2. Tangent of 60, I see is root 3. Cosine pi over 4 is root 2 over 2. Or 2 over root 2, which gives us 2 root 2 over 2, or just root 2. Now, pi over 6 is the same thing as 30 degrees. Pi over 4 is the same thing as 45. And pi over 3 is the same thing as 60. Cosine pi over 6 is root 3 over 2. Cotangent 30, well, that's 1 over the tangent of 1 over tangent 30. Tangent 30 is root 3 over 3, which gives us negative 3 over root 3, which gives us, when you rationalize the denominator, gives you negative root 3. All right, cosecant negative 2 pi over 3. Negative 2 pi over 3 sits in quadrant 3, and that's 1 over the sine of negative 2 pi over 3. And so sine of negative 2 pi over 3, the reference angle is pi over 3. And in quadrant 3, sine's negative. So that's negative root 3 over 2, or 2 over root 3, which turns into negative 2 root 3 over 3. Sine of negative pi over 3, well, negative pi over 3 is in quadrant 4. Reference angle is pi over 3, so this is the negative of the sine of pi over 3. Pi over 3 is 60, so that's root 3 over 2. Let's see, 495. 495, that's 360, which leave us with 135 degrees, which puts us at quadrant 2 with a reference angle of 45 degrees. So this is the same thing as the sine of 45 degrees. I just don't know if it's plus or minus. But in quadrant 2, sine's positive. Sine of 45 is root 2 divided by 2. 13 pi over 4. In some sense, radians are easier because I know that this is a reference angle of pi over 4. I just don't know if it's going to be positive or negative until I know what quadrant 13 pi over 4 is in. If I were to go around, there would be 1 pi over 4, 2, and 3, and 4, 5, 6, 7 pi over 4, 8 pi over 4, 9, 10, 11, 12, 13 pi over 4 sits right there. I'm in quadrant 3, and that's where tangent is positive. So we use the positive of tangent pi over 4, and tangent of pi over 4 is 1. (22 pi over 3), well, I know that that is a reference angle of pi over 3. I just don't know if it's positive or negative yet. 22 pi over 3, it's going to take a little while to count on that one. So I'd like to shave off some of my 2 pi's and see where I lie. Four would be 12. 2 pi, 4 pi, 6 pi would be 18. 8 pi would be 24, so that's too big, so 6 is it. (22 minus 18 is 4 pi over 3. Okay, so I recognize that 4 pi over 3 as a pi over 3 past pi. Reference angle, we said was pi over 3. We're in quadrant 3, and that's where sine is negative. Sine of pi over 3 is root 3 over 2. Last one, number 59. We've got a plus or minus of the cosine of the reference angle pi over 6. We know that the cosine of pi over 6, which is 30, is root 3 over 2. I just don't know plus or minus yet. That's kind of the hardest part. Negative 35 pi over 6. If it was a 6 pi, that would be three times around. And so 6 pi take away 35 pi over 6. Is 36. That's a pi over 6. So we're just 2 pi, 4 pi, it's just a pi over 6 shy of that. And so that's going to be the positive. Okay, so that concludes the review for sections 1.3 and 1.4.